In our last recording, we reviewed information about inverse trigonometric functions. Now we want to look at the derivatives of each of the inverse trigonometric functions. Each one of these derivatives have a rule. The derivative for the inverse sine of u is 1 divided by the square root of 1 minus u squared times du dx. Now notice it says the absolute value of u has to be less than 1 because remember, all sine values are somewhere between -1 and +1. These cannot be 1 or -1 because that would make the denominator of our derivative function 0. Now, when we look at this example, our u here is going to be x squared. So that's our u function. So the derivative of the inverse sine of x squared is 1 divided by the square root of 1 minus x squared squared times the derivative with respect to x of x squared. X squared. That will give us 1 divided by the square root of 1 minus x squared squared is x to the 4th. We multiply exponents times the derivative of x squared. We bring the 2 to the front is 2x to the 1st, or 2x. So the derivative of the inverse sine of x squared is 2x divided by the square root of 1 minus x to the 4th. So to find the inverse, or the derivative of the inverse sine of u, we apply this formula. There's also a formula for the derivative of the inverse tangent of u, that is 1 divided by 1 plus u squared times du dx. So if I want to find the derivative with respect to x of inverse tangent natural log of x, I will apply this formula, and that will give me 1 divided by 1 plus, since my u is natural log of x, I will have natural log of x squared in parentheses, and then I'll have to multiply by the derivative with respect to x of natural log of x. That gives us 1 divided by 1 plus natural log of x squared times, and remember the derivative of natural log of x is 1 divided by x. So that gives us 1 divided by, when I multiply the bottoms, I'll leave that factored out and leave that as x times 1 plus natural log of x squared. So we can find the derivative of inverse tangent of u using this formula. Next, the derivative of the inverse secant of u is 1 divided by absolute value of u times the square root of u squared minus 1 times du dx. So here, our u is 5x to the 4th. So the derivative of inverse secant 5x to the 4th will be 1 divided by the absolute value of 5x to the 4th times the square root of 5x to the 4th squared minus 1. And this is times the derivative with respect to x of our u function, which is 5x to the 4th. Now as we simplify, notice we have the absolute value of 5x to the 4th. And the absolute value of 5 is positive. And since x to the 4th is always positive, the absolute value of x to the 4th is always going to be positive. So the absolute value of 5x to the 4th is just 5x to the 4th. Under our square root, we have 5x to the 4th squared. Be sure to square the 5, which is 25, and square the x to the 4th by multiplying our exponents. 4 times 2 is 8. This is times the derivative of 5x to the 4th. Remember, that's a power rule. We have 4 times 5 is 20, x to the 3rd. Now as we multiply these, notice that I have this 5x to the 4th here, and 20x to the 3rd here. And I can simplify that. 5 goes into 5 one time, 5 goes into 24 times. I also have x to the 3rd and x to the 4th. Remember, you subtract exponents and you'll get 1. That x to the 1st power will be in the denominator since 4 is bigger than 3. So that leaves me with just a 4 on top. in the numerator, and in the denominator I have x times the square root of 25x to the 8th minus 1. Now each of the other inverse trigonometric functions also have rules for their derivatives. You'll notice that they are very similar rules. The rule for the inverse derivative of the inverse cosine of u is the opposite of the derivative of the inverse sine of u. The derivative of inverse cotangent of u is the opposite of the derivative of the inverse tangent of u. The derivative of the inverse cosecant of u is the opposite of the derivative of the inverse secant of u.